Okay, I think we were talking about the network address, okay, where all the host bits will be 0 except the network bit. Okay, you can understand it later once we complete the classes. Okay, why exactly this 10.0.0 only? Okay, why these 3 bits or octet belongs to host, and why in this IP address that belongs to only 2 hosts belong to host, and why only this 1 host belongs to host in the this particular IP address. Okay. So for all the IP address of version 4, the network address is what? 0.0.0.0. This is, I can say, mother of all version 4 IP addresses. Okay. This is called as what? This is a network address of for all 4.3 billion IP addresses. 0.0.0.0, which we use in default routing. Okay. Next is a broadcast address. Broadcast address means what? This is the address used by the application or a host to send the information to all the nodes on the network. That is called as what? Broadcast address. That means if you want to send the same packet to all the nodes which are connected in the network, in that case, we have to use this particular broadcast IP address. And for all this, all network, okay, all network means what? 4.3 billion IP addresses. The broadcast address will be 255.255.255.255. This is a broadcast address of all the network which are present in the IP version 4. Okay, this is the initial number and this is the last number. That's the reason it is called as what? Network address, and this is called as what? Broadcast address. Wherever you find 0 in any octet, just understand that belongs to the network part. Okay, that is a network address, I can say. If you find any 255 in any octet, then you consider it as a broadcast address. Understood? Clear? Next, we have some classes in the IP version 4. Okay, we have some 5 classes in the IP version 4. Yes. So whatever the number we have, that is 0 to 255, we just made the classes of it. We made some 5 classes out of it. Okay. So where the first class, that is class A, which is ranging between 0 to 127. This is called class A. And class B is having 128 to 191. Class C is having 192 to 223. Okay. And class D is having 224 to 239. And that is reserved for multicasting. Okay. And class E is having remaining 240 to 255. And that is also reserved for some reason, that is research and development purpose. Okay. So we use only first 3 IP classes. Class A, class B, class C. We don't use class D and class E because they are reserved for multicasting and R&D purpose. Okay, we don't use these two. And even if you try to assign this IP range to your system, they'll not take. They say it as they are reserved for some reason. Okay, they use only these 3 classes. Understood? This class D is used by the multicasting. Yes, we are going to see some of the multicasting IP addresses during our Cisco networking. Okay, I mean all these networking devices, they use some multicast addresses. Okay, so that they will be from this particular range, 224 to 239. Okay, and class E is, I mean, that is also you can't use because that is given to research and development of defense. Okay. Yeah, you were asking, right? The private IP address range. These are the private IP addresses range. Example. The same thing you can take example. Okay. Hmm? Example. Okay. See, we have, I said like we use only first 3 classes. So out of that classes, they have taken one network, okay, as a private IP address. Yes. So if we see here in class A, they have taken whole 10 network, whole 10 network. Okay, that means in this one, in a single network, okay, that is 10 network, will be having 1 crore plus IP addresses. In this IP address, okay, we have some 1 crore plus IP addresses in a single network, single 10 network. Okay, because we have 3 host parts. 3 host part means what? We have 24 bits for the host assignment. 2 raised to 24. If your mathematics is really good, you can calculate this one. Okay, you may get it up to 1 crore something. Understood? So in this particular network range, we'll be having 1 crore IP addresses. Okay, the range is starting with 10.0.0.0. This is a network address to 10.255.255.255. This is a broadcast address. Okay, and whatever the IP addresses will come between this range, they are called as what? Valid IP addresses that we can assign it on the host devices. Host device means what? Like our laptop or PC or anything. Okay, inside the local network. Like I assigned yesterday. I shown you, right? I assigned it on router and as well as on the PC device. Same like that you can assign. Okay, just to make the local communication. Okay, after that in class B, we are having the range of 172.16.0.0 to 172.31.255.255. This is the range they have given for the private IP address. Okay, they are starting with 16 and they are ending with the 31. Okay, wherein this 172.16 and 172.31, they belongs to the network, and remaining 2 host. What we are remaining to octet, okay, they are belongs to the host portion. Okay, that is nothing but 16 bit they are given for the network, okay, and 16 bit they are given for the host. That means 2 raised to 16, 65,535. Okay, this is what the total number of IP addresses we can get in a single network of class B. Okay, so here also we are going to get some total. In this range, we are going to get some 1 crore plus IP addresses. Here also. Done. And the last one, in class C, we have given a range that is 192.168.0.0 to 192.168.255.255. This is a private IP address range from the class C. Okay, where we are having 3 for the network and 1 for the host. That is 2 raised to 8. That is nothing but 256. In a single network, we'll be having 256 IP addresses. Clear? Okay. Network addressing, the network address, which is also called as a network number, which uniquely identify each network. Every machine on the same network shares the network address as a part of IP address. For example, if I'm having this IP address, that is 172.16.30.56. Okay, here the network address is what? 172.16.0.0. This is what the network address. And whatever the 30.56 you can see, this is the host address that we are given on a single host. Okay, you can see here 172.16, which represents the network address, and remaining 30.56, they can be anything. Okay, next we have subnet mask. Okay, for each and every class, not each and every, only the first 3 classes they are having subnet mask. We don't have subnet mask for class D and class E class, IP addresses. We have subnet mask only for the class A, class B, and class C, because we are using only these 3 classes. Okay. So subnet mask means what? It is also kind of a 32-bit address that is going to segregate an IP address into network bits that identify the network and host bits that identify the host device operating on that particular network. Okay, what exactly is this one? It is going to define which octet belongs to network, which octet belongs to the host. Okay, if that is, you can see here, this will help us to determine which network IP address belongs to which class. Okay, if the class A, if we consider, the default subnet mask of this one is 255.0.0.0. That means whatever the first octet we have, that belongs to network. Remaining all three belongs to what? Host. Okay, wherever there is a 255, that will belongs to the network portion. Wherever there is a less than 255, that belongs to the host. It may be 0 or it may be less than 255. That all belongs to the host. Okay. And in class B, the default subnet mask is what? 255.255.0.0, where the first two octet belongs to the network and remaining two belongs to the host. And class C subnet mask is what? 255.255.255.0, where the first three belongs to network and the only last octet belongs to the host. Okay, that means we can't vary this first octet in the class A. We can't vary the first two octets in the class B. We can't vary the first three octets in the class C. We can only make changes in wherever there is a 0. Okay, that too between 0 to 255. Okay, we can't give 0, we can't give 255. That means we can only give 1 to 254. Okay, if I give it 0, then that goes to the network. If I give it to 255, then it goes to the broadcast. Okay, so that's the reason if you want to have a valid IP address, if you want to be assigned it on a particular host, then you have to use a number between this 1 and 254. Am I clear? Clear? Okay. Any question online? Online?
I'm good. Thank you.
Okay, you can see here the same thing. I just try to give it an image here. Okay, class A subnet mask. I hope you already know that class this subnet mask is also having a 32-bit numbers. Okay, so 8-bit, 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 8-bit. Again, 4 octets. Okay, so the first octet that belongs to network and remaining all belongs to what? Host. In class A, that means here network bits are like 8. Okay, and host bits are 24. Okay, total it makes like a 32. Okay, when it comes to class B, the first two octet belongs to network. Okay, and remaining two belongs to the host. That means we have 16 and 16. That is again 32 bits. Okay, and in class C, I said like the first three belongs to network. That we don't vary. Okay, that means it is total exactly opposite of the class A, where we had 8 network bits and 24 host bits. Here we have 24 network bits and only 8 host bits. That is 32 bits. Okay, and I already said you the class D and class C don't have subnet mask because they are reserved for multicasting and research and development of defense respectively. Okay, clear? Next, we'll jump into the classes. First one is a class A address. That is 0 to 127. You already know that. Yes. So in a class A address, first octet or byte is assigned to the network address. Yes. And the remaining 3 bytes or octets are used for host addresses. Then the format will be like network.host.host.host. And the default subnet mask is like 255.0.0.0. Okay. For example, this one 49.22.36.12. Okay. Here in this IP address, 49 is the network address and 22.36.12 is the host address. So every machine on this particular network will be having the different IP address from this 49 network. Getting my point? 49 network address. Yes. And each class address has a 3 byte for host. 3 byte means what? 24 bits for the host address for the machine. So this means there are total 2 raised to 24. How many IP addresses we can have in the class A? 2 raised to 24. That means 1 crore 67 lakh 77,216. That means if you take this 49.0.0.0 IP address or a network, inside this, how many IP addresses we have? How many IP addresses we have? 1 crore 67 lakh 77,216 IP addresses. Okay, inside only one network. It will go up to 49.255.255.255. I mean, between this, how many IP addresses we have? Like this. Getting my point? So this is only one network. Like that, how many network we have? 0 to 127 networks. Getting? So we have 0 network, we have 1 network, 2 network, 3 network, like this up to 127 network. Out of it, we have taken only one network address, that is 49.0.0.0. Inside that, how many IP addresses we have? 1 crore plus IP addresses. Understood? Yeah. But still, we're exhausted of this IP version 4. Even though having 1 crore plus IP addresses in a single network, still we are exhausted. But that is in a private network. Okay. So yeah, unique combination, and therefore precisely that many possible unique node addresses for each class A network. Because node addresses with a 2 patterns, that is all zeros and all ones, are reserved. What do you mean by all zeros and all ones? If I take the same IP address, that is 49.0.0.0. Okay, all 0 and all ones, they are reserved. Okay, all zeros means what? We have to consider this host bits. If it is all 0, then we consider it as what? Network address. Okay, if it is all ones means what? All zeros and all ones, they are talking about binary numbers. Getting my point? If you convert this into binary number, we'll get 8 zeros here. If you convert this into binary number, we'll get again 8 zeros. Like this, how many? 24 bits will get as a 0. If all 24 bits are 0, then that is a network address. If all 24 bits are 1, that is a broadcast address. If I'm making all of them as 1, then obviously I'm going to get it as a 255. Yes. So 255.255. This is called as what? Broadcast address. And we never assign this address to any host. Okay. We never assign the 49.0.0.0 to any host, and even we don't assign this 49.255.255.255 to any host, because they are network address for 49 network, and this is a broadcast address for 49 network. They are reserved. Okay, that means in a single IP address, okay, we'll get 1,67,77,000. It was 200 to 600. 214 IP addresses. I did -2. Why -2? Network address, and second is a broadcast address. Understood? Sure. Can see the same thing here. Yeah, for each class A network, because the node address with the patterns of all zeros and all ones are reserved. And the actual maximum usable number of nodes for a class A network is what? 2 raised to 24 minus 2. Okay, that is nothing but 1,67,77,240. Clear? This is what the total number of IP addresses we can get in a single network address.
ನೆಟ್ವರ್ಕ್ ಮಾಡಿದ್ರೆ ಮತ್ತೆ -2 ಎಕ್ಸ್ಟ್ರಾ ಆಗ್ತದೆ.
ಯಾವ
ಈಗ ನೆಟ್ವರ್ಕ್ ಐತೆ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ಸರ್ ಮತ್ತೆ ನೆಟ್ವರ್ಕ್ ಅಂದ್ರೆ ಬ್ರಾಡ್ಕಾಸ್ಟ್ ಅಂತ ಮತ್ತೆ ಬೇರೆ ಬೇರೆ ಇರ್ತಾವ ಮತ್ತೆ -2
ನೀ ಸಬ್ನೆಟ್ ಆಗತ್ತೆ, ಸಬ್ನೆಟಿಂಗ್ ಆಗತ್ತೆ. ಅವಾಗ ಮಾಡ್ತಿದ್ದ ಕಡಿಮೆ ಆಗುತ್ತೆ. Okay, class A valid host IDs. So here is an example like how to figure out the valid host IDs in a class A network. So if all host bits are off, then that will be what? The network address. That is, for example, 10.0.0.0. This is what? Network address, where all host bits are 0. Okay. If all of them become 1, that will become what? Broadcast address. That is nothing but 10.255.255.255. Here. And whatever the numbers or IP addresses will get between this range, they are called valid host IDs or valid host IP addresses. Okay. The valid host are the number of in between the network address and the broadcast address, which is starting with 10.0.0.1 and ends with 10.255.255.254. Yes, we can assign 255, but we can't make all of them as a 1. Okay, if I make this as 2, this also as a 255, that will become what? Broadcast address. Okay, you can see the same thing here. Notice that zeros and 255s can be valid host IDs. You can see here, I have assigned the IP address, this kind of IP address to the PC. Okay, yes, I said like the host IDs can't be 0, but not all the host time at the same time. Okay, at least one should be 1 there. At least one host bit should be high. Then it is called as what? Host address. If we make all the 24 bits as a 0, then that will become what? Network address. If we make all of them as a 1, that will become what? Broadcast address. Okay, but it is okay to have this 0 or 255 inside the host IP address. Okay, but the thing is like all you need to remember when to trying to find the valid host address is that host bits can't be turned off and all at the same time. Clear? Is it clear? Okay. Next, we'll talk about the design of this class A. Why they have taken class A range from 0 to 127 and how they have taken this as. Okay. The designers of the IP address scheme decided that the first bit of the first byte of the class A address must be always off or 0. This means class A address must be 0 and 127 in the first byte. Okay, whatever the first octet we have, first byte we have, in that first byte, the first bit is always kept as a 0. Okay, so they keep it as a 0 and remaining all as a variable. Variable means what? They can be either 0, they can be either 1. Okay, if I make all of them as a 0, the first bit is always 0, and remaining also, if I make all of them as a 0, 0, then this is a first range of the class A, that is 0. If I make all of them as a 1, what you will get? How? Convert. How you convert this into decimal, and how exactly it is 127? Hmm? Exactly. So you have to add this 64, 32, okay, and then 16, 8, 4, 2, 1. And here we'll be having 128. And 128 is 0. Okay, and you have to add only this. You will get it as a 127. This is a last range of the class B. Okay, same thing they said here. Let's consider the following network address, that is 0 and all x. So if we turn the other 7 bits all off, then turn on, you will get it as a 0 and 127. That is a exact class A range. And here also, let me tell you, 3 networks are reserved. In this class A range, 3 networks are reserved. What are those? One is 0 network, and second is a 10 network, and third one is a 127 network. 0 network means what? It's a network address for all the 4.3 billion IP addresses of the version 4. That is nothing but 0.0.0.0. This is reserved. We can't use it on any kind of host address. Okay. And 10 network, we already know that it is given as a private IP address range. The whole 10 network, 10.0.0.0. Okay. And last one, that is 127.0.0.0. This is also reserved for some reason. Does anybody know why exactly it is? As what? Yeah, that is correct. That the system will use for itself. What it is called as? No. Yes. Online. Mr. Bosu, Vaishnav, are you there? Mr. Gopal Krishna,
Yes, sir.
have you heard about this 127 network ever?
No, sir.
Okay. Mr. Pradesh, do you have any idea? Okay, this is called as what? Loopback address. What is in loopback address? This is used by the system itself just to check the internal this is used for testing purpose. Okay, this is reserved in class A. Which are the three networks are reserved in class A? 0 network, 10 network, and 127 network. Where 0 is a network address for all the 4.3 billion IP address, and 10 is a private IP address from the class A, and 127 network is a loopback address range. Clear? It will go up to 127.255.255.255. Clear? Understood? Yes. Next, we have class B. In a class B network address, the first 2 bytes are assigned to the network address, and the remaining 2 bytes are assigned or used for the node address. Then the format will be like network.network.host.host. Then the default subnet mask will be 255.255.0.0. Okay. For example, an IP address, you can take this one, 172.16.30.56. Okay. Where in this IP address, the network addresses are 172.16. This belongs to the network, and remaining, whatever the 30.56 you can see, that belongs to the host. Okay. Okay. So how many host bits we have here? How many host bits? 16 bits we have. So 2 raised to 16 if you consider, that's nothing but you will get 65,536 IP addresses in a single host, single network I can say. Okay, single network means what? We have, what is the range of this class B? 128 to 191. That means in just 128 IP address network, in this network, how many IP addresses we have? Up to 128. Yeah, 128 network. Okay, how many we have? 65,535 addresses. Okay. So with the network address being 2 bytes, that is 8 bit each, you get 216 unique combination. But the internet design decided that all class B network address should start with a binary 1 and then 0. Now they are talking about the design of this one. Okay, you can see here. They kept the first bit of the first byte as 1 and second bit as a 0, and remaining they are variable. Okay, so if I make them all as a 0, so 1 and 0 they are constant, and remaining as a, this will become what? The first starting range of the class B, that is 128. Okay, if I make all of them as 1, 1 0 1 1 1 1 1 1, so this will become what? 191. This is the last range of the class B. Okay, so class B address using 2 bytes for the node address, this is 216 minus the 2 reserved patterns of all zeros and all ones. That means you will get 65,534 valid or possible node addresses. I said 65,536 minus 2, 34. Okay, so this is what the node address will get in a class B of each class B IP address or network I can say. Yes. So how to find the valid host ID in the class B? If you consider this one, that is 172.16.0.0. If all host bits are 0, then that is called as what? Network. And if all host bits are 1, that is called as what? Broadcast. Okay. This is about the class B. And next is class C we are having. Here the first 3 bytes of class C network address are dedicated to the network portion of the address with only one merely byte remaining for the node address. Okay, then the format will be like network.network.network.host. What is the default subnet mask of this one? What is the default subnet mask? 255.255.255.0. That means the first three belongs to the network and last octet belongs to the host. Okay, for example, you can check this IP address 192.168.100.102, wherein 192.168.100.100 belongs to what? Network address, and 102 belongs to the host address. Okay. So how many host bits we have? 8. That means 2 raised to 8. 256. That means minus 2. 254 valid IP addresses we can get in a single network. Okay. Now by seeing these three classes, what you found? What you understood? Just suppose like if I'm having a big network, okay, where I want a lot of IP addresses, then which class you suggest me to use? Class A, obviously, because there it is having in a single network, okay, we'll be having 1 crore plus IP addresses. Okay, and if I'm designing a medium size network, then you'll go for class B. Okay, if you're having some 50,000 plus IP addresses need, then you can go with the class B. Okay, then if you have very small network, then you can go with the class B. Okay, I mean 256 or 254 is also not a small number, and no one will be having this much what do you call system in a small network. Okay, so if you're designing for the small network, you can go for the class C, and if you're designing for medium network, you can go for the class B, and if you're designing for the large network or a complex network, then you can go for the class A. Here, so here we'll be having 254 IP addresses in a single network. This all same. So class C, valid host ID. So where all host bits turned off, that is what? Network ID, and all host bits turned on, that is called as a broadcast IP address. You can see here 192.168.100.0, that's a network address. Okay, 192.168.100.255, that's called as a broadcast address. Whatever the number we'll get between these two, they are called as what? Valid or usable host IP addresses. The first valid host IP address will be 192.168.100.1, and the last will be 192.168.100.254. Clear? Okay. Next, now they are talking about the design of this one. Okay, what they have done? They just kept the first 3 bit as 110. These are constant, and remaining as what? Variable. Okay, if I make all of them as 0, then I'm going to get the first range of that class C, that is 192. Okay, if I make all of them as a 111, 110, this is constant. Okay, and remaining as 1111, then I'm going to get the last range, that is 220. Okay, this is what the design of it. So if you see the IP address that start at a 192 and goes up to 223, then it is like belongs to the class C IP address. Okay. Now I have a question. Look at it and answer me. Which class this IP belongs to? Which class this IP belongs to? Class B.
No, class A.
Class A. Okay. Class A. Okay. How many of you say class A? Yes. Which class? Class A. Class A. A. ಯಾವ class of? Class C. A. Class A. Okay. Online. Both of you said class A. Okay. Next, Mr. Pradesh, Gopal.
It comes in class A, less
Okay.
than 127.
Mm-hmm.
Class A, sir.
But I say it as a invalid IP
Oh
address.
yeah, the third one is 256, right? Third octet.
That's why I said look at that IP address and answer me. Okay. Do we have 256? No. The maximum number we can get, that is a 0 to 255 maximum. Purposely I have given it as a 256 just to notice. It is an invalid IP address. Okay. If I make it as 250, you can take. Okay. Now it is a valid one. Then obviously it is going to be class A. Because always if you are watching any IP address, you have to watch the first octet. Always you have to watch the first octet. Just forget the remaining octet, whatever it is having. Okay, just see the first octet. Yes, 116. This is the number which is between 0 and 127. Yes, so that belongs to the class A. So that means it is a class A IP address. Clear? Am I clear? Okay. Now, which class? Class B. Why?
Class B. The range of class B is 128 to 191.
Yeah, the range of class B range is 128 to 191, and this is a number between that. Okay, understood. So how to identify the class of that IP address? Okay, based on that, you can have the subnet mask. If you know the class, okay, you can have the subnet mask, because the default subnet mask of the class A is what? 255.0.0.0, and class B,
255.0.0.0.
class C.
255.1.1.1.
Good. Next, we have class D address. As already said you, the class D and class E, they don't have any kind of subnet mask. Okay. Now we'll see what is the range and how they designed this one. So IP address belongs to class D. They are reserved for multicasting. And the higher order bits of the first octet of the IP address belongs to class D is set to 1110. Okay, that means the first 4 bits of the first octet, they are reserved as 1110 and remaining as a variable. If I make these variable bits as a 0000, then I'm going to get the first starting range of this class D. What's the range? 224. Okay, if I make all of them as 111, 1110, 1111. So that will be the last range. 239. Sure. 255. How come, man? 239. Okay, the answer is here only, you can see. Okay. So class D does not possess any kind of subnet mask. And the IP addresses belongs to class C range from 224.0.0.0 to 239.254.255.255. This is a class D range. Clear? And a class C address, IP addresses belongs to the class C are reserved for experimental and research purpose. Here IP addresses of class C range starts with 240. 240.0.0.0 to 255.254.254.254. Why they have taken 254? क्या हो जाएगा किसका?
It will become universal broadcast.
Yeah.
All 255.
It will become the universal broadcast address for all those version 4 IP addresses. Okay, but now we are defining what is the range of this class B. So that's the reason they'll take it up to only 254. Clear? So this doesn't, this class also doesn't have any kind of subnet mask. And the higher order bits of the class, first octet of the class C, always set to 1111. This is the design of that one. Again, the first 4 bits of the first octet, they kept it as a high. Okay, and remaining as a variable. Yes, so if I make it all of them as a 0, then I'm going to get it as a 240. If I make all of them as a 1111, then I'm going to get the last 255. Clear? These are some information about the classes of the IP address in detail. Yeah. Next we have the versions. Okay. So after this, we are going to complete this IP addressing. So tomorrow we'll be starting with the subnet. Okay. So we'll just finish this quickly. So you already know something about this version 4. Okay. Version IPv4 stands for what? Internet Protocol version 4. It is a primary version of the brought into the action production within the ARPANET in the 1983. And the size of this is what? 32 bits, which will be expressed in a decimal number. For example, you can see this one, 192.16.0.1. Okay. And IP version 4 could be numeric address and its bits are separated by a dot. Okay. We're talking about any number, a decimal, dotted decimal, or a binary number or a hexadecimal. All are separated by with a dot. Okay. And here in this type of IP address, we have 3 types. Unicast, broadcast, and a multicast style of IP addresses. And the total number of IP addresses we can get in a version 4, that is 2^32, because the size of this version 4 is what? 32 bits, obviously. Okay. Then 2^38 means what? Approximately 4.3 billion addresses. Okay. Next comes the IP version 4. So total size of this IP version 6 is what? 128 bits. According to that, the total number we'll get, that is a 340 undecillion. Okay. So here IP version 6 is represented in a hexadecimal number. So one single hexadecimal character is equals to 4 binary bits. Okay. So one single portion or a segment of IP version 6 size is 16 bits. You can see here, this is what a beautiful IP version 6 IP address. Okay. How many segments you can see here? And let me tell you, these are separated by colon. What you are seeing in the IP version 4? They are separated by a dot, and here each segment are separated by a colon. How many segments like that you can see here? 8 segments. 1, 2, 3, 4, 5, 6, 7, 8. In a single IP version 6 address, we will be having 8 segments. Okay. And each segment size is what? 16 bits. So how come it is? If you convert this particular one number into binary, what you will get? 0, 0, 0, 1. And the 2, 0, 0, 1, 0. And next is 6, 0, 1, 1, 0. And A is nothing but what do you mean by A? 10. What is the binary number?
1084211 1010.
1010. So how many bits we have here? 4, 8, 12, and 16. So the single segment is having 16 bits. So like that, how many segments we have? 8 bits. So if your mathematics is really good, you can calculate this one. 128 bits. So this is the size of IP version 6 address. Okay. So next we have this, yeah, we'll discuss it later when we'll be discussing about the IP version 6. There again, we have to discuss it again. So I'm not going to discuss it here. Yeah, 6th point is what? One single segment will be equals to 16 bits, what we have seen now. And total number of segments we have, that is 8. And the total IP version 6 header is 40 bytes. What is the IP version 4 header size? What is the size of IP version 4 header? 20 bytes to 60 bytes. And this IP version 6 header is having constant header size, that is 40 bytes. Okay. And there is no requirement of NAT and PAT protocol in the case of IP version 6. We have some two protocols, translation protocols. Okay. Network address translation and port address translation. Okay. Where it will allow us to convert or map this private IP address to the public IP addresses. But here in this case, in the case of IP version 6, we don't need that one, because we have almost 340 undecillion numbers. So we don't need to translate anything. Okay, they are more than enough. Whatever the number we have, they are more than enough. We can even do the one-to-one mapping. Okay, in that case also, we'll never be exhausted with this IP version 4 IP addresses. Sorry, 6 IP addresses. So by default, router device supports IP version 4 addresses. Keep this in your mind that whenever you are doing the routing with the help of IP version 6, you have to enable the IP version 6 manually, because the router doesn't support IP version 6 by default. They support only IP version 4. Okay. And there is no use of subnet masking in IP version 6. Obviously, we don't need IP version 6 subnet masking. Next, there is no concept of broadcast address in the IP version 6. We don't have any broadcast address in the IP version 6. Yes, we have one more type, that is a anycast address. We'll discuss later, don't worry. And IPsec will be enabled in case of IP version 6 by default. IPsec is nothing but what? It's a VPN protocol. Okay. So by default, it will be enabled on the, in case of this IP version 6 on the router. Okay. And there is no use of ARP protocol. Instead, we have a NDP. We have a protocol called ARP. I think I discussed when I was discussing about the switch device, right? Address resolution protocol, which will help us to know the unknown MAC address. Okay. So here also we use one more protocol, just same like the ARP. We call it as a neighbor discovery protocol. Okay. And we have 3 types in the IP version 6: unicast address, multicast address, and the anycast address. These are the 3 types of the IP version 6 addresses. Clear? This is about the IP addressing. Any doubt here? No? No doubt? Sure? Okay. So tomorrow we'll complete, the whole class will complete the subnetting. Okay. And then, not tomorrow, Monday. Monday we'll start with the subnetting. Okay. After that, from Tuesday, we're going to start with the practical. Okay, that is with switching part. Clear? Great. Yeah. Mr. Gopal, Bosu, Pradesh, Vaishnav, any question?
Arun, share the drive access.
I think I did.
No, I not get any mail.
Is it? Let me check. Just be there only. Please give me a mail ID.